you can see, get into the actual CNC machine and production machines, and you can get the idea of it. So here the G43 two length compensation. G43, G44, G43 is, please make a note of this. G43 is two length compensation, it is positive. G44 is two length compensation, it is negative. And G49 is two length compensation cancel. Two length compensation. It is not TCL, it is not standard method abbreviation by which we are going to write. Just avoid writing, I am writing TCL. Two length compensation positive. G44 is two length compensation negative. G49 is two length compensation cancel. These are the things. And next, explain the peck drilling they will be giving. Peck drilling. So sometimes you could not able to answer them properly. You can take a suitable example. Suppose, for example, in a material, I want to drill a hole of 50 mm length. I want to do a drilling of 50 mm length. If it is a finite hole, a small hole is there. Initially, we are going to create this hole. Continuously, we can drill it very small. And how the scrap will be coming out in the drilling operation? How the scrap will come out? Pardon? No, it will be coming in the form of a continuous chip or simply in the form of discontinuous chip. That is one. And where is the provision for the movement of the scrap from the depth? Fluid, there will be a spiral structure will be there. In that gap, this will be moving. And in case of the CNC machine cutting tools, is there any cooling systems in the drilling machines? In the fluid itself, there will be coolant circulation method will be there. Coolant will be circulated within this one. In normal drilling, what we are going to do, we are going to pour the coolant. But in the fluid, there will be a spiral shape, a small holes will be provided. Through this, the coolant will be circulated. So that these tools will be very costlier. You understood? These will be costlier. And now, what is this peck drilling? I want to do a 50 mm depth hole. So continuously I am not going to do it. So I want to do it in a stages of 5 mm. First 5 mm I am going to remove inside, take it out, add another 5 mm, it will be 10 mm, again take it out, add another 5 mm, 15 mm, like that. In every step I am going to add up 5 mm, 5 mm depth of the drilling. So that is called as peck drilling. A peck drilling is a method or a measuring process employed in the drilling operation. Instead of continuously drilling the hole, in a standard steps we are going to drill the hole. Maybe in steps of 3 mm or 5 mm or 8 mm based on the type of material. Correct? So this peck drilling will be G73. Peck drilling. Yeah, right? You can understand peck drilling? I am going to give every time a standard depth of not 5 mm, whatever it is a standard. For the beginning 3 mm, next 4 mm I am not going to give. In a peg drilling, a standard depth we are going to give, that will be taken as a standard. Okay, understood? That is called a peg drilling. And this is the path of drilling I have shown. Path of drill I have shown. And G80 will be indicated CAD cycle cancel. G80 CAD cycle. What is this CAD cycle? What is the meaning of CAD cycle? Actually, while you are going to do the machining, maybe it is a threading operation or a drilling operation or some other standard operations. Therein, the CAD cycle is another one sub-program that will be added into a main program. You understand? So the threading is one CAD cycle. It is CAD cycle. That particular CAD cycle, you are going to give the type of profile and how much depth is required, and it will be performing the threading operation. A CAD cycle is a particular cycle, that repetitive cycle meant for this particular project only. Maybe it is a threading operation, maybe it is a drilling operation, or gluing operation, whatever it is. It is a standard. Okay. If you want to do a gluing also, gluing cannot be done once at a time. We cannot probably cave. Slowly we have to remove the material. Correct, no? So that also required a CAD cycle. A standard profile in terms of a particular depth, it will be removing the material. That will be CAD cycle, and that will be a sub-program that can be added into a main program always. That can be added into the main program. Okay, and you understood? So what happens in the standard of the programs? In the beginning, we will be writing a program name. The program name will be written. Of course, in our computers, we are not going to store them properly. In a manufacturing level, every day they may go for many programs. For example, my particular X organization is giving us for the machining work. And it's not simple work. It may be complicated job. For this complicated job, the profile structure will be provided by those people in the form of drawing, and the programmer will be reading the drawing properly, and he is writing the program, he do the testing, then he stores it into the computer. And after this, after 1 year or after 1 month, I may get the same order, so I can retrieve this particular program from my stored programs. And I will be calling this particular program by the name of the company which they are giving us. And the date and the name of the company, if you write, that can be retrieved from the programs. You understood? So the block will be given a headline. So what kind of program it is, which company or organization has given, on what date. So the programmer need not to write the program frequently. It is not required. And this program also can be edited. And one possible way of doing the test is the offline testing. Today, so many computer simulations can be done without I am going to play it onto the actual machine. As we discussed in the previous class, acid test or a trace test, it is not required. I can do the computer simulation. You can see, you have done the computer simulation, correct? No? Not done the program by doing the machining in the actual machine, correct? No? We do created the program, and finally we are going to simulate the tool movement. Finally, what geometry you get, correct? No? That is the simulation we do in this one, computers. In the similar way, that particular geometry will be created, and frequently we are going to test them. Form of a 3D model, and I can just similarities I can find it out. What actually I need to do, what I got. If any changes are required, those can be done. Finally, once I assume that it is correct, then I can play it into the action machine. Okay, so these are the important the strength points of using the modeling softwares and simulation softwares in the machining activities. Okay, then next drilling cycle, G81 drilling cycle, and G83 is peg drilling cycle, G90 is and absolute and incremental zero. What is this? Absolute and incremental. No, we know that. Absolute is we are taking a particular reference. Incremental is we are going to take the previous line or baseline as a reference to define next. So both the ways we can do the programming. So many of the programmers in some of the very unconventional type of machining will be taking the absolute, and in some other cases will be taking the incremental. But in most of the cases, as I told you, the float zero we are going to define on the table. With reference to that, we are going to do the dimensioning. So absolute zero will be taken. The incremental sometimes will be taken. Correct, no? And what are the coordinate positions? What are the coordinates? You can see here, in case of billing table, suppose this is the table, billing table, this right bottommost corner will be the coordinate, fixed coordinate of a machine. The fixed coordinate of a machine will be defined here. With reference to me, I am telling. With reference to you, it will be here. Correct, no? That will be fixed for a particular machine. And if you want to create any particular point as a reference, the float zero can also be used. Okay, fixed zero and float zero, those are also two things. And G90 and G91 are absolute and incremental. Okay, these are things you need to remember them. And now kindly open your this one mobile, look into, and spread it to other